So welcome back. So far we have discussed what is logic family, its classification, and how to construct a different logic gates using CMOS logic. And also I have given some assignment questions. You can send those assignment question answers to the mail ID represented in the slide. And if you have any doubts, you can contact through either phone or mail. Now in this session, let us see first of all CMOS logic levels. Actually, so applying logic 0, logic 1, what does it mean? That means applying a voltage value to the logic 0, similarly a voltage value to the logic 1. But these are not the fixed voltage generally, they are range of voltages. In case of CMOS logic, 0 volts to 1.5 voltage range is considered as logic 0. 0 to 1.5 voltage range is considered as logic 0, whereas 3.5 volts to 5 volts voltage range is considered as logic 1. Okay, that means if any voltage in the range 0 to 1.5 volts, that is treated as the logic 0. Similarly, if any voltage in the range 3.5 volts to 5 volts, that is treated as logic 1. Suppose if the voltage in the range 1.5 volts to 3 volts, that is not considered as either logic 0 or logic 1, because this is a range called undefined range. If any voltage in this range, that is not considered either logic 0 or logic 1. Coming to different voltage notations which we are using, also called voltage parameters, they are like this, that is VIH, VOH, VIL, VOL. Here the first subscription represents is it input or output, whereas the second subscript represents is it with reference to logic high or logic low. Okay, so let us see. VIH means high level input voltage. Therefore VIH means high level input voltage. VOH means high level output voltage. VOH means high level output voltage. Similarly, VIL means low level input voltage. And VOL means low level output voltage. And whatever this minimum and maximum means, that you can understand in the coming slide. Here I represented one diagram with reference to input and output. In both the cases again I represented logic high voltage range, similarly logic low voltage range for both diagrams, in both the diagrams. Okay, and also I represented all these voltage notations. Let us see why VOL is the maximum. So this is the range for logic 0, and this is the value of maximum value under logic low. That's why VOL is the maximum. Okay, so maximum low level output voltage, it is called maximum low level output voltage. Similarly, in case of logic high, this is the minimum value, this is the minimum range or minimum value. So that's why VOH is called minimum high level output voltage. Similarly, at the input side under low level, this is the maximum value, that's why it is called maximum low level input voltage, VIL. In the same way, under logic high, this is the minimum value, that's why it is represented as VIH minimum, that that is minimum high level input voltage. Minimum high level input voltage. Input voltage. I think you are clear about these voltage notations. Why some are minimum and some are maximum. Okay. Let us see the typical values for these voltage parameters. So the typical value for the VOH is VDD minus 0.1 volt, and VIH is estimated as 70% of VDD, VIL is 30% of VDD, and VOL is ground potential plus 0.1 volt. So based on the VDD value, you can estimate all these voltage values. Corresponding to these voltages, let us see the current notations represented here again as IOH. IOH means high level output current. High level output current. This is also called sourcing current. This is also called the sourcing current. Next, IOL means low level output current. Low level output current, also called sinking current. Also called the sinking current. So IAH is high level input current. High level input current. Whereas IAL is low level output current. Sorry, low level input current. Low level input current. Okay, remember all these voltage and current notations. Then let us see some important parameters related to logic families. You know, every system has some parameters. Based on those parameter values, usually we are checking those values whether is it suit to our requirement or not. Suppose if you want to buy a cell phone, what are the parameters you are usually checking? The weight of that cell phone, screen size, resolution, camera, etc. parameters we are checking before going to buy a cell phone. Similarly, with reference to logic family, the important parameters are noise margin, fan in, fan out, transition time, propagation time, and power consumption. So these are the some important parameters. Coming to noise margin, what is noise margin means? It represents the tolerance, the tolerable noise voltage. Noise margin means a tolerable noise voltage.